So this is exercise 1.3 and we're taking a look at question 7 from the Year 1 Further Maths textbook. So have a look at the two shapes. The rectangle is the object that is transformed into the parallelogram, and we're given an angle A-DA, which is 60 degrees, and for part 1 we need to find the coordinate of A'. So I'm going to draw in a vertical line, drop down a perpendicular like that from A to the x-axis, and notice, because it's a parallelogram, A' is not directly vertically above C'. C' is slightly to the left of A'. So let's focus on this triangle, which has A' at the top right vertex, D' or D, because they are actually the same point, on the bottom left, and at the right angle we have this point here, which I will call point M. Now, because this angle here is 60 degrees, we know that this angle here is 30 degrees. Now, we know it's a horizontal shear, so we know that point A' is level with point A, which means that the height of our right-angled triangle is 2 units. This then allows us to calculate the distance between point M and point D'. So we know that tan of 30 degrees is equal to the opposite 2 over the distance between point D' and point M. So we can rearrange this to give us D'(M), which is equal to 2√3. Now, that doesn't give us the coordinate of A, it gives us this horizontal distance between here and here. So to get the x-coordinate of A, we need to find out what this shorter distance between here and here is. So we use the fact that this distance is 1 unit. Don't worry about the x-coordinate of D being a negative value. Think about the fact that the blue distance that I've drawn out and the green distance together make up this black distance from D' to M, which is 2√3. That blue measurement is 1 unit, which means the green measurement, which goes from 0 up to that point M, is equal to 2√3 minus 1, and that is the x-coordinate of point A'. So point A' has coordinates 2√3 subtract 1, comma 2 for its y-coordinate. Now, to find the matrix that represents the shear transformation, we know it's a horizontal shear transformation, so we know that the matrix is going to be of the format 1, 0, K1, where K is our shear factor. And there are lots of ways in which we can calculate the shear factor. One way in which we can do this is to think about the point A as it is transformed to the point A'. And what we can do is we can find out the distance between A and A'. So A' has an x-coordinate of 2√3 minus 1, and A has an x-coordinate of minus 1, so the distance between them actually works out to be 2√3. And we can also work out the distance of A from the x-axis, which is equal to 2 units because its y-coordinate is 2. And then you may recall that the shear factor can always then be calculated by the first value, which is here, being divided by the second value, which is here. So the shear factor is 2√3 over 2, which is equal to √3. So that is our value of K, which tells us that our shear matrix is 1, 0, root 3, 1.